I'm going to talk about the sandwich theorem, also known as the squeeze theorem. You have the sequences an, bn, and cn, and they're related to each other in such a way that cn is either bigger or equal to bn is either bigger or equal to an. And with such relation, you can take the limit of an and it is equal to the limit of cn, which is equal to L. And as you can see, if cn and an have the same limit and bn is in between those, that means that the limit of bn is also equal L. You can see this relation on a graph with an going to a certain number, cn going to the same number, and bn being in between them. No matter what way bn goes to, it still goes to the same limit as an and cn, because it is sandwiched between them. Now that we know what the definition is, I'm going to start with the first exercise. We have the limit of 3n plus minus 1 to the power of n divided by 5n plus 1. And now we can take this sequence and write it again. And now we need to find something that is bigger than it and something that is smaller than it. I'm going to start with the bigger one. I just need to rewrite 3n plus and something that is bigger than minus 1 to the power of n. You can take any number you want, so I'm going to take 100 and just rewrite 5n plus 1. And as you can see, this sequence is bigger than the one previously written. So now we can just calculate the limit of this one. Now we need to divide it by the biggest power of n, and in this case it's just n. So I'll write 3n divided by n plus 100 divided by n divided by 5n divided by n plus 1 divided by n. As you can see, this goes to 0. This also goes to 0. 5n divided by n goes to 5, and 3n divided by n goes to 3. And from this equation you have 3 divided by 5. Now you're going to do the same thing, but just making the middle equation smaller. I'll take 3n again, plus something that is smaller than minus 1 to the power of n, so I'm going to take 0. All this divided by 5n plus a number that is bigger than 1, so 100, for example. Now you also need to calculate the limit of this sequence, and you do it exactly the same way as the bigger sequence was done. So you take 3n divided by n plus 0 divided by n divided by 5n divided by n plus 100 divided by n. Those two numbers without n go to 0, and the other two go to 5 and 3 respectively. And your limit is equal to 3 divided by 5. Now if you look at the results of both the smaller sequence and the bigger sequence, you can see that they are equal. So that means that the sequence in the middle also has to go to 3 divided by 5. Now I'm going to start solving the second exercise. You have the limit of the n root of e to the power of n plus 3 to the power of n plus pi to the power of n. Now I'm just going to rewrite this. And find a sequence that is bigger than the one in the middle. You can see that pi to the power of n is the biggest number amongst those three, so I'm just going to rewrite it 3 times as the bigger equation. Now that you have the bigger sequence, you can calculate its limit. If you have 2 numbers under a root, you can separate them into 2 roots. From the n root of 3, you get 1, and you can rewrite pi as pi to the power of 1 divided by n to the power of n. And those two n's erase each other, and from that you have left pi. Now for the smaller sequence, I'll just take pi to the power of n. And you also need to calculate its limit. And I'll write the pi just as I did in the bigger sequence. And from this you also have left pi. So from the smaller sequence you've got pi. From the bigger one you also have got pi. So that means that the one in the middle also has to be pi.